One of the subjects that Martin Gardner took on was quantum mechanics. Now, it's been puzzling the great minds for over a century. So why is it so hard to figure out what it means? This is from Steven Weinberg, Nobel Prize winner. Why is it so hard to figure out what it means? Because it says that the subatomic world is governed by two things. One is a wave function, which is not observable or measurable, and therefore not real in any normal sense, and only tells you probabilities that real options might happen. The other is that something happens to that wave function, such as a measurement or observation. This causes the wave function to collapse in the jargon, leaving behind one of those options. You know that one option will appear, but which is only a matter of probability. And here's the kicker. This uncertainty is not epistemological, but ontological, meaning it's not just that the option is out there and fated to become real, and we just don't know it. It's that there is no fated fated real option out there before measurement, just the probabilities. It's as if there are two worlds, classical and quantum. So what's the puzzle? There are many, and you know some. One is that here's a well-known one. There's a book outside about this. You've all heard of it. It surfaced in popular culture in the 1970s, just shortly before Martin Gardner wrote about it. Suppose there's a cat in a box. Okay, that's not weird. Cats love getting in boxes. But suppose there's something else inside the box triggered by quantum action, like a radioactive substance connected to a vial of acid, able to kill the cat. The fact that everything inside is quantum mechanical means that there's a quantum mechanical thing, means it's governed by a wave function, meaning that the reality of the two options, the cat being dead or alive, depends on some measurement. And this is how Martin Gardner put it. Here's another puzzle. Suppose you have someone, we'll call him Wigner, looking at a quantum phenomenon in a room. And suppose you have someone else, we'll call him Wigner's friend, looking at him also in a room. And a third, each seems ontologically wavy to the next. This is how Martin Gardner put it. So the implications seem to be for some of the great minds of physics to say that, as Martin put it, the external world has no well-defined structure. Why was he bothered? Here's why he was bothered: because of its implications. He didn't like the first ones, and he was really terrified of the next one. It seemed the origin of a lot of pseudoscience. So how do we get out of this? There are several proposed solutions. Here are two of them. One way is to say that quantum mechanics is incomplete. Just let the great minds work on it a little bit more, and we'll find the well-defined structure, but this hasn't worked. The other way is to say it's complete. The well-defined structures out there. In fact, there are an infinite number of them. We just can't see them all, but this makes hash of the meaning of reality. So, and there are other attempts. So, when Martin turned to quantum mechanics, which he did here, we all held our breaths, hoping that he would restore objectivity, structure, reality to our world. At last, we'd get the answer. And the solution was, his solution, well, he didn't have one. He couldn't face the implications. He was disturbed that he said, we have to believe that there is something else that we haven't found yet. So can this puzzle be solved? Let's go back to Weinberg. Why was he bothered? Think about what's odd here. Of course, Weinberg knows what quantum mechanics means. He knows how to calculate with it. He knows how to make predictions with it. He knows that there are practical things designed with it. They all work. He knows the implications. He sees the reality in the world all the time. So he expects what's odd here is that he expects that meaning requires tracing everything back to something with a definite property, object, structure, traditional objectivity. And he's afraid that if you can't get that, we'll have a rising tide of pseudoscience and quantum woo. Is there another suggested possibility? Well, here's one. It's called quantum Bayesianism. In Bayesianism, probabilities represent the quantification of degrees of belief or uncertainty in a subject. The simplest example being coherent betting behavior in a roulette wheel. There's nothing subjective about it. The probability is out there in the roulette wheel. Applied to quantum mechanics in cubism, probabilities are treated as normative rather than prescriptive, as a guide for decision-making of what to expect. In QB, measurements don't affect nature, but simply the judgments of the measuring subjects. So it's a radical attempt to resolve puzzles of quantum mechanics by treating the probabilities not as features of reality, but of subjects understanding and coping with reality. So this seems to eliminate all the puzzles, the traditional puzzles and paradoxes of quantum mechanics. The collapse of the wave function becomes an updating of your experience. Locality returns to physics because quantum correlations aren't experienced by a single agent at a single time. The human role is minor, but not entirely absent. It's not of scientists setting up equipment to make reality, it's that they're thinking and understanding the often changing world in which we find ourselves. So we don't see the world in cubism, we don't see the world as if through a pane of glass. We find ourselves always already in a world that's ours, a world of changing structures. So, do you think Martin would have found that meaningful? Thank you.